Legacy code is code without tests. If you have code and it has lots of tests, then it's relatively easy to change. If you don't have the tests, you're really in serious trouble. It's a strong qualitative difference between those two different types of code bases. If you want to teach good design, basically teach people the things to avoid, and everything that's left is good design. I was kind of shocked in the beginning to see your vendors basically go and say, hey, we're going to write all your tests for you. Yay. And as a TDD guy, you're looking at this and you're saying, oh my God, no, right? But for characterization testing, it's really kind of powerful because people are getting much more realistic now. I think in the very beginning, people started going and extrapolating and they just get completely freaked out by the possibilities, right? But I think many developers now have had enough experience with AI that they realize it's not going to replace them anytime soon. At the end of the day, in the legal system, you can't go and say, oh, the algorithm did it. It's like, no, a person who works at a company did this. At the end of the day, we are responsible for what we do.
Hello guys, welcome back to another new episode of the Tech Lead Journal podcast. I'm very excited today to meet Michael Feathers. So we kind of met 9 years ago in one of his workshops back then in Singapore. So I think today is the first time we met again after that such a long time. So Michael, really great to have you here. Welcome to the show.
Great, thank you very much.
Right, Michael, for people who may not know you, so maybe in the first place, can you help to introduce yourself? Maybe telling us a little bit of highlights or turning points in your career that we all can learn from.
Sure. So my name is Michael Feathers, and I guess the thing I'm best known for within the industry is writing a book called Working Effectively with Legacy Code. And I was involved in the early Agile movement before it was even called Agile, right? And I spent a lot of time since then just helping people with legacy code and refactoring issues. And yeah, that's just been a thing I've been very much interested in. Prior to that, I spent about 9 or 10 years programming, worked in various roles through the technical hierarchy. And yeah, just worked kind of gone on from there.
Yeah, so I think your book Working with the Legacy Code, right? I think now it's in the 20th anniversary. So congrats for that.
Yeah, thanks for reminding me. I forgot what year was in the 20s. So,
yeah, so I think it's one of the so-called classic software programming books, I would say, especially people who are dealing with legacy code. So maybe let's start from that book first, right? So since you're well known about that book. So legacy code, right? So in the first place, why did you write something about legacy code? I guess people back then may have started working on some legacy code that is difficult to work on, or that's something that you learn along the way.
Well, it's kind of interesting with that. So I went to a conference and I met Kent Beck and Ron Jeffries back in 1999 or so. And I was starting to go and get to know some of the people that were involved in the very early Agile movement, as I mentioned. And it was interesting because I learned so much from them. It was interesting because at that time, I was a good programmer and everything, but they had really thought deeply about how to become better programmers. So I wanted to refactor, and I was doing a bit of that back in my workplace. And they were also saying things like, you should write your tests first. Why would you do it any other way? And I thought this is kind of a very bold thing for them to go and say, but then I understood after I did it for a while. And it helped me realize I could reduce the stress of programming a great deal. And so after that, I was hired to be a consultant. I left the tech job that I had. And the job was to go around to different places and help them acquire the technical practices that are part of Agile, right? And invariably, it's kind of like you run into this situation where people have tons and tons of code and they just don't know quite what to do with it, right? It's hard to refactor. And you look at Martin Fowler's book from back in that day, and they said, okay, and a snippet is kind of like, here's all this refactoring stuff, but you should have tests. And if you don't have tests, you're in a bit of trouble. So I just realized that this was a problem. And I just started collecting techniques for going and breaking dependencies and getting tests into place. And yeah, it's been an interesting ride that way. But it's also been really kind of fascinating for me because I started as a mathematics major in school. And I had this interesting idea of kind of being an introvert, of course. I read about this mathematician named Paul Erdős, and it was he lived with a suitcase and would go from place to place and sort of work with other mathematicians. And the cool thing was he didn't even have to have a piece of paper or a pencil to do this, right? He just had conversations and do these things. I thought, wow, that's really an interesting thing to work on mathematics and just make it purely your life. But then I kind of realized it's kind of if you're doing that, you're not really helping people, right? Directly. So I've had much more fun going and working with people and realizing that I can make a bit of a difference. And going back to my book, as much as it's very technical and has a lot of code in it, I'm only realizing now how much it was really about going and helping people keep their morale up and have a positive outlook to what they can do and know what they can do within code base.
Yeah, I think the book itself, although it has been 20 years, I think it's still pretty relevant because people nowadays still work on legacy code. In fact, there might be
Mhm.
more legacy code than last time before, right? But in the first place,
Yeah.
let's go back to the definition itself about legacy code because some people might have different perceptions, different definition. Some people think it's like old legacy code. Some people think it's code that they just don't want to touch or they don't understand. In your book, actually, you have one good definition that is probably interesting, right? You mentioned something related to tests as well in the very beginning. So maybe let's go to your definition. What is legacy code actually?
I've got many definitions, but the one I'm kind of known for is basically that legacy code is code without tests. And it's funny about this because this happened when I was working with a team and had another consultant with me. And I got frustrated at one moment and somebody asked a question. I said, legacy code is code without tests. That's just what you need to know, right? And my friend, the consultant, he basically said, you got to put that out there. That's really a powerful statement to say. And I knew at the moment that it really was at odds with the traditional definition. You get code from other people and that becomes legacy code, right? Or code that you're scared of and don't quite understand. But I think, with all these definitions, they're pragmatic in a way because they're used to highlight something that you basically want to change. With this one, it was really just I had this intuitive sense that, if you have code and it has lots of tests, then it's relatively easy to change. If you don't have the tests, you're really in serious trouble. It's a strong qualitative difference between those two different types of code bases. And so I was trying to get that across. But occasionally people say, who are you to make the definition of legacy code? It's like, it's just one. There's many. Pick whichever one you want. Pick the one that helps you. I think it's the best thing to say like that.
Yeah, so I think in the context of your definition, you have emphasized a lot about testing, right? I think in the very beginning, you mentioned you learned from Ken Beck about test first. Maybe in the
Yeah.
refactoring book, also it was mentioned that you refactor also along with the test. Why the test is so important in your opinion?
Well, I think the main thing is because, and this is going to be kind of like getting almost philosophical in a way. It's kind of like most all of us walk around with an idea in our heads about what the system does. And the thing is, it's kind of like the system has its own idea about what it does. It's not an idea, it's what it does, right? And I think that that's an interesting thing. We quite often get so caught up with what we think the system is doing and what we want it to do. And we forget to even think about what it currently is doing, right? So to me, that's a very grounding perspective. It's kind of like if you really know what the system does, you have a great base point to go and decide what to do next, right? And over again, I've run into situations where people, once they learn a bit more about what the system actually does, they have different ideas about what's possible. And they're kind of like, it's kind of like people have been asking for this particular feature. And now I see it would be relatively easy to add that feature, right? I've always been sort of like saying, it'll take 3 weeks to do this sort of thing, but now I know it's much easier to do. And without that baseline of knowledge, you just really don't know that. So we talked about tests first a second ago. One of the things I talk about in the book is something I call characterization tests. And quite often people call this like pinning tests now sometimes. And the idea is that basically you write tests that you use to describe the current behavior of the system. So you're not writing them first, you're writing them after the code has been written, and you're writing them to go and ask a question of the code base. And once you get the answer, you basically take that answer and you put it in as the expectation. And sometimes this is called golden master testing in a way, or considered like a poor practice. But I think when you have existing code without tests, it's just a way of going and actually understanding what you've got. And you can basically put that off to the side and distinguish it from the test that you write first to go and actually sort of, trigger you towards creating feature and understanding when you're done. So yeah, that's the thing to me. A test is a way of grounding our knowledge of a system for the most part.
Right. When we refer to the tests, are you referring to automated tests or are you referring also for other types of tests? Like, I don't know, people have manual tests, UI tests, regression tests, so many other tests out there, right? So are you specifically referring to just automated tests or something else?
Yeah, generally automated tests. It's kind of like it seems like I'm finding fewer and fewer places that still do much manual testing at all, right? And I think it's, especially with like DevOps and the Accelerate book and everything like that, it's the idea is to go and get something in place with tests and have it out there within an hour if you can, right? So there doesn't really leave much time with that. So generally, I am talking about automated tests. Yeah, it's kind of funny. I think most of the people that are like thought leaders in the non-automatic testing space have really kind of moved into calling it exploratory testing and basically going and accenting the fact that as somebody who basically has ideas about what a system could be doing, you can just sort of verify those and look for really terrible things and make people aware of them, right? So that's an exploratory approach.
So I think talking about testing, right? Although it has been around for many, many years, right? I think still the state of the software development practice these days, testing is still kind of like lacking in terms of quality, in terms of quantity. And I know that you have written this book since 20 years ago. Do you think the definition of legacy code still kind of like relevant, or is it something changing because with so many other tools, techniques, and also maybe now with AI? So is the definition still kind of like appropriate, or do you think something has evolved along the way?
Well, if you don't have any tests, I think it's appropriate for you. I guess is the best way to go and put it, right? But I think, we might end up in a place where legacy just reverts. And I think it has to some degree to basically the thing that we don't understand, right? And I think that's another definition is like legacy code is code we don't understand. So yeah, there's a lot more that we can do now in order to go and actually understand the systems that we have. I've been using AI for this quite often, just like taking a lot of code and sort of like putting it into a session and asking questions about it. And, the results have been mixed. I can kind of see the advantages to this now. And I'm thinking we're kind of like due for, let's see, it's August 2024 right now, right? We're due for this kind of backlash of people saying, oh, we're just making things up. And it's not going to help me as a programmer and stuff like that. But, you can pay attention to the social wins of things. But I think that this technology is only going to get better over time. And it's really important for every programmer to learn how to use it well and understand what its limitations are. So.
Yeah. I think speaking about legacy code, right? I think almost all developers, I believe that they hate working with legacy code, right? No matter what, right?
Mm-hmm.
So either that they don't know what the code is doing, either the code is buggy, or the code is just so outdated that you can't even change it to using the modern practice and things like that, right? So in your consulting, I'm sure you have seen the worst of legacy code, maybe, and some which are
Yeah.
probably not so bad. But if you can tell us a little bit, what are some of the typical challenges that people, when they deal with legacy code, why is it something that is kind of like avoided or hated a lot in the software development?
I think the mindset has a lot to do with it. And I think also there's the ambition of creating a new system, right? And it's kind of like, it seems with a lot of modern systems, you can, you may be working with older code, but you get to go and sort of like create this little space where you have, say, a new service, and you can write the code from scratch and do this. And you get very happy about this because you get to sort of display your creativity. But some people actually enjoy debugging, right? Some people who enjoy debugging, right? It's the same kind of thing in a way. It's this thing of trying to understand something. And I think I might be sort of like more predisposed to this than most people because from being a kid, I've just always been curious about everything. Anything I could read, I would just sort of read, and try things out and that sort of thing. And if you approach it as an adventure, I think that's something which is really kind of good in a way. Reminds me of a story, and it's not directly about the technical work, but I was working with a team many years ago, and it was interesting because I was there for like 4 or 5 months on and off. And, at the end of this, the guy who brought me in, he brought me into his office. They showed me these graphs. They showed me how the quality had improved through all the time that I'd been there. We really, made a big difference. And I thought, well, this is weird because I feel like a failure. Why do I feel like a failure? And what it was, this was like early days, like 2000s, like the dot-com bust and all this other stuff. I was working at a startup and everybody thought they were going to be a millionaire. And then they discovered they weren't going to be a millionaire, right? And it's just this interesting thing of kind of like, I started saying to friends, I was like, wow, it's, the thing which really affects whether we feel good today or not is what our expectations were, right? And it's, and I talked to a friend who was like in Eastern religion. He's like, yeah, that's a Zen thing. It's like, okay. But it's like, it's really an interesting thing. It's like our expectations set our experience to a strong degree. And I think if you can actually cultivate the curiosity about what does the system do, right? Or the desire to help people in that context, it can be very, rewarding work. You may just have to go and put aside your expectations a little bit. So.
Yeah, you touch on just now something that a lot of developers probably like to do, right? Which is to create new system or rewrite everything,
Mm-hmm.
right? So since you write the legacy code book, what is your approach towards fixing the legacy code or maybe refactoring the legacy code versus rewrite, right? So when should we actually contemplate doing rewrite versus fixing the legacy code?
Yeah, a lot of it comes down to business reason rather than technical reason, because at the end of the day, the technical things just kind of like, we can deal with anything, it's a question of whether there's payback for this particular thing, but the business case needs to be made. It needs to be understood that you don't have to rewrite an entire system most of the time. You can concentrate on the things which basically are going to have growth in the future and also, are presenting difficulty to you in the meantime. Usually what I like to do is I like to go and actually like try to do some refactoring, try to do some planning for some refactoring, look at prospective features, and then having all that stuff together think about whether a rewrite is justified or not, right? As I mentioned a little bit earlier, this thing of going and actually doing spot rewrites on particular things is really pretty powerful. And quite often for people, it's like an all or nothing proposition. And that's really a horrible position to approach these things from. But yeah, the thing with rewrites is that it's great if you have tests. So if you have tests, you're really in a golden space. If you don't, then you're kind of like dealing with the situation of like, oh, I need to write this thing and I don't understand what it does. And it's like, okay, well, now you got two problems, right? So I think that's really just the best way to kind of approach it. The thing is, that's one that's rewrite when you basically are dealing with technical debt directly. But there are these other rewrites which are really all about architecture that really have, a different set of considerations leading into them. And these are the architectural ones are usually like, much more extensive.
Speaking about architecture, right? So some people to the extreme, right? Like doing microservice. So the one part of the definition of microservice for some people is like if you can rewrite the whole service within, I don't know, X days, right? Then that's a microservice. So with that kind of maybe well-designed microservice, you can do that. So what's your take about this as well, right? Like when you refactor the application into a different service, is that also some strategy that you can do for tackling legacy code?
Yeah, definitely. I think it's an interesting thing to actually move things around to different places. And so it's really at a macro level, the same thing we do as a micro level, at a micro level with classes in many ways. But as far as that thing of like, should be able to rewrite in a day or so, I think that's a great goal. Hard to see it in practice though. It's really a weird thing. I think there's this intrinsic thing about software that basically tends to grow and grow and grow. And quite often it grows to the point where you basically have, it's hard to go and do anything like that, but it's snuck up on you, that kind of thing. I remember like reading through some research years ago about like how big does a class need to be before you actually go and refactor, right? That kind of thing. And looking at actually like quality data, it's kind of like where do we have the most bugs and the biggest abstractions are the smallest ones. Turns out the answer is really the ones that you touch the most often, right? So it's kind of like we all have a feeling for when things get to be too big, but quite often it's kind of like there's no set point. It's kind of like a subjective sense in a way. But yeah, I think there's a lot of stuff that was a dream for microservices that I think is, it's a shame that we kind of fell away from some of that stuff. The thing of being able to use almost any language, be able to throw things into production almost immediately, being able to go and rewrite them when we need to. And yeah, I don't know. I tend to think that with a lot of these things, it's kind of like we only get the resilient systems we need when we stress them a bit. If there's a reason to start rewriting things, then it's good because we actually gain the skill to do this and don't think of it as being an atypical thing, right? So it's actually good when there's a bit of stress in the environment, So.
Speaking about how people tackle this legacy code, right? Maybe from your experience or maybe some summary of your book, right? What are the techniques that people can evaluate or maybe people can try to actually tackle legacy code in a much elegant way, so to speak?
In terms of that, I think the main thing is really to go and figure out exactly where you need to make changes, right? And then you move outward from there. They may be cases where you need to change 2 or 3 lines in a method, for instance, or you need to go and actually sort of like you add 5 or 6 methods to a class, but maybe you're thinking about creating a new class. And then what you do is basically you think about what would be involved in getting tests in place for each one of those places. And you kind of like crawl the tree upward and see if there's a common place for those changes. And you try to pragmatically figure out where you want to go and have your tests. Now, if you have code that doesn't really have very many tests in place, chances are the code isn't really able to accommodate tests yet. And you have to do quite a bit of dependency breaking work in order to go and actually put the tests in place to go and solve these problems. And that's really what my book is mainly about, is going and breaking the dependencies and writing the tests to go and do these things. But at a micro level, that's what you kind of need to do, right? I think in the more macro level, the important thing to go and remember is that essentially this is the kind of stuff where you're never going to go and have complete tests on code base unless you started that way, right? And that it's okay to live in this limbo space, and you probably will for a long period of time, where you're going to have some areas of great coverage and other areas of not so good coverage. And that's just normal, right? But at the end of the day, the cool thing is that the things that you're about to change right now, chances are you'll be changing them in the future. So what you do to go and get tests in place for those things, it's really kind of valuable if you need to go and actually start to make changes later, and chances are you will. So you're going to start to get like very quick returns from doing this sort of thing. Like you'll be thinking, one day that's like, wow, I need to go and get in this area of code, and there aren't many tests, or the tests aren't very good. And it's going to be a pain when I do that tomorrow. And then you get there tomorrow and you're always like, oh, damn, well, one of my teammates was in there 3 weeks ago and they put tests in place, and wow, yay, my job is easier than it was before. So I think there's that, but there's also, I guess, the psychological thing of basically doing that enough to get to the point where you notice the difference about how it feels we have an area of code that's easier to work in versus one that doesn't. Quite often I run into people that have, even independent of whether you have tests or not, they're not used to working in a good code base at all. And so they're in pain, but they don't know they're in pain, right? And that's really a tragic situation to be in. So.
Yeah, speaking about some of the techniques you mentioned, like dependency breaking and being in the limbo situation, you have this one concept called seam, right? So I think that's really a powerful thing. Maybe if you can, define what is seam and how should people use it within their code base.
Sure. It was kind of funny because I thought of this and I actually wrote a chapter in my book. It came very close from going and pulling it out because I thought it was just a peculiar way that I'm seeing software and it wouldn't be beneficial to anybody. What it comes down to is this, that essentially when you look at a class or a set of classes, there are places where it's easier to go and actually sort of replace things, replace behavior than other places, right? So let's say you have a method and it's basically doing something crazy with IO and you want to get it out of your way so you can write tests for the class without actually doing the IO, right? If it's a virtual method, right, you can basically go ahead and override it in the subclass and then it's out of your way. So that part of the method is a seam. It's kind of like a seam on your shirt. It's a natural breaking point where you can actually go and replace one thing with another, replace one behavior with another. It's interesting about this because if you start to categorize all the seams, there's just like lots and lots of them. But it's an opportunistic way of looking at software to go and say, what can I do to actually, without changing things drastically, be able to go and get areas where I can get understanding and coverage? Because quite often it's like if you're going to make the change and you don't have all day to go and like refactor everything, you're going to have to go and get that change in a way which is not going to be disruptive, has very high quality, things along those lines. And it just might be a spot change. And it's good to know where that's possible. So.
Is this seam concept similar to the Strangler Fig kind of strategy when people are doing microservice, like, or re-architecting certain parts of their API or their service?
Not really. I mean, to me, it's like with Strangler, it's kind of like what you're doing is you're kind of like building things in parallel. You're diverting flow to one area of the system so you can go build out another one. And it's like my favorite, before it was even sort of like written up as a pattern, it's like I used to live in Miami, Florida. And there's like this giant bridge, a 7-mile bridge that goes from South Florida to Key West. And it was kind of funny because many years ago, what they did is they're kind of like, okay, we've got the old one. We're going to build a new one next to it. And then we're going to go and tear down the old one. Right. And it's just, I looked this up one time. I think it's like parallel replacement is a term that people use in other engineering disciplines, this kind of thing. But generally, that's what Strangler Fig is. It's just this thing of going and actually sort of selectively rewriting areas by going and allow yourself to go and have the old path to fall back on. So in terms of seams, I guess you do have to find seams in order to go and actually understand where you can make these diversion points. So I guess that's the commonality.
Right. Thanks for the clarification. One thing that is always very tightly coupled, right, with the legacy code is this practice called refactoring or, writing tests, maybe TDD as well. So maybe in your view, right, is it very important for us to be able to do refactoring right or refactoring well? Should we also read Martin Fowler's book in order to be able to tackle legacy code better?
Totally. I think it's really, it's a great book. And it's kind of funny. My daughter many years ago had a friend who was thinking about getting into programming. And he's like, oh, what should I do? What should I do? And I gave him a copy of the book, Refactoring. And the reason I did this was kind of like there was, I think it was Ralph Johnson who said this many, many years ago when the book first came out. He said, it's kind of interesting that basically, if you want to teach good design, basically teach people the things to avoid and everything that's left is good design. And that's really the way the book is organized. It's kind of like, okay, here's all these code smells. And your job is to go and look at these code smells and get rid of them. And if you do, your design's going to be better than it was before. It's a great way of going and conveying design sense, kind of like what is better than the other thing, right? So I think it's a very valuable thing just in terms of understanding systems. But in general terms of dealing with systems, it's extremely valuable because refactoring is all about clarifying things to the point where basically you can understand them and where change becomes easier. It's not just refactoring itself, but understanding the predecessors, like the code smells I mentioned, but also design principles. So you kind of understand what direction to carry things in. And once you have that, you're going to just be able to go and sort of like make things better for yourself in the future and the people around you. And that's a wonderful thing.
In terms of the structure of automated tests, do you have any suggestion or should we also still refer to the like test pyramid or maybe something around that? Or is there any kind of like suggestion that you would advocate people when dealing with legacy code?
Well, I think for the most part, one of the things that's kind of funny is that there was like BDD, behavior driven development, that came out many years ago, right? And one of the interesting things there is they were concentrating on like high level behaviors and sort of writing tests that would deal with collaborations of classes at once. And it took me a long while to realize that, I'd run into people all the time that are writing like one test case class per test per class, right? And that you're in this weird situation with that. But invariably, when I'm working with legacy systems, I'm trying to find some vantage point that I can write tests at, which isn't too far from the behavior I'm actually going and covering, but goes and covers, the behaviors that I care about, right? And these clusters are really more than just one class quite often, right? That's just the way things go. So I think that the conversation we have about whether something is a unit test or an integration test is not terribly productive in a way. I think it's really about testing behaviors. And, there's many other people saying this as well as I am, but it's just a really valuable thing to go and look at is that you're testing behaviors. So you need to go and find the places where it's best to do that and kind of move forward with things. So testing pyramid, you've got unit and you go all the way up to like acceptance and stuff like that. I guess the thing to say is that you can basically, the lower level tests that you have are things that you build upon in terms of understanding the system. And there's no way generally to go and have tests at an extremely high level and cover everything you care about, right? So it's kind of like I try to concentrate on the lower levels and then know that's to make the higher levels easier when I need to go and approach those.
Yeah. So what about if you mentioned something very interesting about behavior, change of behavior, right? So I think the business most likely will demand a lot of changes, right? And
Mm-hmm.
some program actually are not touched because some business does not demand it to change, right? What do you think in terms of those kind of code, right? For when it happened that we have to change the code, but there is some limited tests. Is this something that is also common in your consulting experience, right? How should people think about code that has been sitting around, still producing value, but one day it has to
Mm-hmm.
change, right? But it's so difficult to change because maybe people have left.
I think generally I'm really, in favor of going and actually just really trying to go and make your changes supported by tests. Okay. Because even though today it looks like nobody's going to change this and stuff like that, it's kind of like it's just the safe thing to do. The fact that you have that code around still means it has value. So you don't want to be in a situation where you're just making it worse, right? But of course, people are going to be pragmatic about this. It really depends upon how much other work they have in front of them and stuff like this. But, I think even going through the exercise of like trying to write tests for something which doesn't have many tests is really, really difficult, gives you an appreciation for, it's like, okay, I'm never going to do this again. And none of my teammates are because we know how bad this is, right? So it's really always a valuable exercise. Try to get the tests in place to support the change you're going to make. But the other thing I want to go and mention with this is that this is not an uncommon thing. It's kind of like, people in business all the time are trying to figure out how much to invest in particular things in terms of like investing in the current line of business, basically going and creating new lines of business and stuff along those lines. And we have the same thing as technical people. There are no easy answers to this question. I think it's important to know that just going into it. So.
Yeah. So one thing that could help us these days is AI, right? So if people dealing with legacy code, maybe some people will play around and try to explain this part of the code base, right? So that you can actually
Yeah.
understand it. So I know that you're also writing this book, AI assisted programming, right? So I assume that you have been
Yeah.
playing a lot with AI recently. So maybe let's go
Yeah, I
there.
have.
How do you think
Sure.
the role of AI in terms of tackling legacy code? Maybe that's the first question before we talk about anything in general about AI.
Well, it's really kind of hard to go and actually sort of see where things are going to go because they're changing all the time, right? And I think the thing that people are most concerned with right now is the hallucination problem, where it's kind of like you ask a question, you get an answer, and you just really don't know whether it's right or not. And I want to take that as a given. It's going to get better over time. But I think the thing that's important is really to go and understand that if you can't trust what's being generated, there still is value there. And I think a lot of this is really about going and exploring alternatives. So it's, if I'm about to do something, quite often I'm like, okay, well, let me go ahead and ask for a different way of doing this. Okay, let me ask for 3 different ways of doing this. Okay, and just compare them side by side and understand what's possible in this space and quite often get ideas I wouldn't have gotten otherwise. For things that we can verify easily, like going and ask a question about a particular API and it gives you the answer. And of course, you put it in place and you find out very quickly whether it works or not. It's kind of brilliant for that. But yeah, I do use it to explain code to me quite often. And I think, God, one thing I love is this thing where you can sort of like, I call it lensing. And it's kind of like you drop in a giant area of code and you're kind of like, okay, this giant class that I have here, what responsibilities does it have? Right. And it goes and gives me a list of them. And usually it's kind of like, so. And you start to interrogate and ask other questions about it. But I love to do this thing where you're like, okay, you gave me 10 responsibilities, just give me 6. basically, if you had to look at this fresh, it's kind of like, what are the 6 most important responsibilities? And by scaling back and forth with this, you start to go and understand, where perception can change of a class in terms of what the responsibilities are, depending upon the level that you're looking at it, right? And it can give you ideas for refactoring. And so I find that very, very useful as a strategy. So there's a ton of other little things like that that are kind of handy. But
So I think these days a lot of programmers have been playing around with AI. I personally also have used it. So I think you mentioned about hallucination problem, right? I think it's also one of the risks. Would AI also create more legacy code because like some people will just take it as it is, right, and then just plug it in and maybe deploy it without even
of
writing a
course,
test to verify it.
of course, there's something. It's the Git Clear report. I think one of the things that they were mentioning there is it seems like there's a lot more churn of code. Code's being put in public repos much faster. There's much more churn and change after it has been, right? Yeah, I mean, we're just going to go and end up in this space for a period of time and everything. The thing that's tough is that it's kind of like it's shifting the balance in a way. It's kind of like it's easier to write code and it's a bit hard to understand it. And I think for me, I'm always dealing with this fatigue issue. It's like I'll look for 3 different ways of doing something. And then I'm doing code review for all these things. And it's kind of like, at what point is that productive and what point is that counterproductive for me? Right. But it's kind of like, we have to review code that other people have written or that we've written a long time ago and have forgotten. And this just goes and increases the burden in that space. And it's kind of tough. I was just say an area that I think is really kind of interesting is the entire thing of going and writing tests, right? Because I was kind of shocked in the beginning to see our vendors basically go and say, hey, we're going to write all your tests for you. Yay. And as a TDD guy, you're looking at this and you're saying, oh my God, no, right? But for characterization testing, it's really kind of powerful because, if you're not changing the code, right, it is a document of what the behavior currently is. And you can go and have tests written for this. And if they pass, then they are actually showing you, real behavior. And so that's useful. I think the thing we have to get used to with this is the idea that tests can be disposable and temporary sometimes and just use them to get insight or to facilitate change. So I think that's a very valuable thing.
Right. So you mentioned about generating test cases, right? And also interrogating code, explaining code, right? What are some of
Yeah.
the other use cases that you typically use when using AI in your maybe day-to-day work?
Well, all the time it's just for exploring alternatives, for the most part. And it's like even things that have nothing to do with code. It's kind of like just, it's an interesting thing to admit. I'm just so curious about things that I have a thought about, something in culture or something in, kind of like science. And it's like, damn, it's like, it's like, how long is the manta ray's, fin in the front? It's like, oh, yeah, there it is, that kind of thing. So it's, yeah, it's an interesting thing. I think in general, any domain that you want to dig into, it's easier to do now. The advent of search browsers gave us a lot more ability to go and discover things and sort of learn things. And now it's off the charts. So I think that's just really, incredible. So
You're writing this book, AI assisted programming. I think it's still in progress, right? Very early in the
yeah.
process, right? So, what made you decide to write a book about AI programming?
Well, it seems like a very strange thing to do considering how fast things are moving. But I think what was interesting to me is I felt like it was an interesting way of going and actually talking more about how we work in a way. And I felt like there are some of the things we confront with AI are things we're confronting with right now, but haven't really talked about all that much, right? And, one of those is that fatigue issue that I mentioned a little bit earlier, right? Let's see, another one is really the thing that sometimes, it's quite often you're working in an IDE and basically gives you code suggestions all the time. And you're looking at this as kind of like, can I accept this? How much trust can I place in this? And the same thing is true with code that you get from somebody else, right? Where's my trust? How do I focus on this particular thing? And then there's the general thing of ideation. One of the sections I have in the book talks about the lost potential if basically you ask a question of AI and you accept the first answer. Because quite often you just ask this prompt again, you get a different answer, a different answer, and a different answer. And I find that so valuable because it sort of opens the possibility space in a way and gets you thinking about different things. It pokes your mind in a different direction, which quite often gives you better ideas about things. And I think that's, a great thing. The other thing as well is that basically it makes us better question askers, right? We get better at it because we have to go and sort of ask questions to interact with it. So it's really a capability amplifier.
So, do you think this prompt engineering thing is one of the skill set that any developers now need to be able to master?
I think so. I think it's going to change. So I think with my book, it's less about prompt engineering and more about approach. But yeah, it's interesting. I think one section I haven't written yet, but I gave an online lecture about it a while back. It's just having a mental model of how these things work at a behavioral level so they can help you with your prompting, right? And just I can very briefly say it's almost like you can imagine you have this giant net, right? And it's kind of like if you ask a question, it pulls some of those things towards you. And then basically you ask another question, it pulls other things towards you. And quite often the way that you ask questions goes to lead you in a different path. So it's kind of like this thing of going in like, what are you pulling into active memory when you're going in sort of like asking questions? I think, little things like that quite often make us better at doing these things.
Yeah.
Very
So I think
serious.
one thing that if we always ask question and we got different answers, right? Obviously, reading the code is like a big cognitive load, right? We try to understand different
Mhm.
ways of doing things, although maybe it end up the same. And also at the end of the day, still the same thing, right? So we gotta write the test for it. So if we don't, actually, it creates a legacy code as well, right? I think reading code is something that I feel is much more important these days, right? Rather than actually writing it, because the prompt probably could use a natural language, and they give us a code and you read the code instead. So in your view, like how can people master reading the code much better? Or maybe sometimes like the design is something that is sometimes it's not appropriate with the larger code base, right? So what's your take about developers taking AI answer and just putting it
Well,
into code?
I feel like everybody knows this, but I have to say it. And so I remember like this story about like somebody is in like high school and they're taking a mathematics course and their teacher goes and says to them, there's one secret for getting an A to this course. And everybody's like, oh, what is it? It's like, do your homework. Okay, do the problems, right? And I think the same thing is true for us in software development. The secret for a lot of this stuff is take smaller steps, right? So if you are looking at generating something, generate something small, right? If you're trying to understand something, paste in something that is kind of small and just get its take on things. If you're just trying to understand with your brain what's going on with something, look at smaller steps and build up from the foundations. And yeah, there's a skill to that sort of thing. I think there's another thing which hasn't been written up all that much that I think is kind of powerful, and it has nothing to do with AI really. And it comes down to basically seeing enough systems that you develop enough impressions of different systems, you start to see what's common and what's different, right? So there's nothing that's a good substitute for going and having very wide experience of many different domains. And that experience, even if you're not hopping from job to job to job, is just reading. There's books, there's open source code and stuff like this. And you start to see how people approach problems differently in different domains. And then when you see something which is totally atypical to you, you have I call it sometimes the coat hangers. It's kind of like you're given all this information and you're looking for the things that are like the basis that you can use to sort of organize your knowledge as you gain more knowledge of the thing you're looking at. And yeah, I think that's a valuable skill to develop as well. So,
Yeah, you mentioned about understanding domain. Yeah, I still think that AI still hasn't reached there yet, right? So maybe like building the
mhm.
whole application end to end, right? And also maybe building a more distributed, complex systems is something that they haven't reached out yet.
Yeah,
So, in your view, what is the ideal, stage where we should rely on AI more versus something that use human creativity or brain more?
I think it's really for the areas which are low risk, and this is kind of funny because there's all different ways of looking at risk. One of the things I think is great is actually to go and develop boilerplate code. So it's like thinking a while back about creating like a Chrome extension. And it's kind of like, okay, just ask it to create like a simple Chrome extension. And it's kind of like, I don't need to write all that code. I can find it very quickly whether it's working or not, right? But I really want to concentrate on the thing that I want the Chrome extension to do, for instance. There's that, but there's also things like that that can be like in-house tools and stuff like that, where you have some confidence that somebody's going to find a problem before it causes loss of life or money, right? That's a very important thing, So I think it's finding these low risk environments. And, a place where this actually kind of works very well is if you're creating tools to go and help you do things with your code, for instance. And I guess, also things like quite often feel like I'm rediscovering shell programming in a way. I've done a lot of shell programming in the past. But when you think about it, shell is perfect for AI generation in the sense that you're basically building from these bigger components, the commands, and it's very easy to find out exactly what a command does. It has wider knowledge of these things than we do, and you can see very quickly whether what it's producing is right or not, right? And it's usually very brief, and you can see what that is. So going and doing that for my work quite often has been a very valuable thing. So yeah, here's that.
I think one topic associated with AI with software programming is that a lot of people are worried about their jobs, right? Or the roles will evolve quite a lot such that you are becoming obsolete or redundant, right? We also see some maybe hype technologies like Devin where they claim they can write code just by itself. So what is your view about, all this worry about developers having to maybe upskill themselves or maybe getting redundant or things like that? So is that something that we have to fear about?
Well, I think people are getting much more realistic now. I think in the very beginning, people started going and extrapolating, and they just get completely freaked out by the possibilities, right? But I think many developers now have had enough experience with AI that they realize it's not going to replace them anytime soon, right? This basically, at the end of the day, it's kind of like in the legal system, you can't go and say, oh, the algorithm did it. It's like, no, a person who works at a company did this. At the end of the day, we are responsible for what we do, right? And I think that's the thing that's, really important for us to go and recognize that there has to be somebody in the seat of responsibility. You have to understand what you're creating as well. So I think we're going to have a place for a long time. And I can't remember the name of the book. I wish I could. Maybe I'll send it to you as show notes if you do that. But this guy basically made the case ages ago where it's kind of like we just need to see ourselves as problem solvers. And programming is one tool to solve a problem, right? And sometimes we can solve problems without writing code at all, and that's great, But we have to basically do that thing of understanding far beyond the code, everything around it, what's the business and all these other things, because all that information makes us much more effective. So I think it's this thing of going and expanding out from our roles a bit. And I think a lot of people kind of recognize that that's just where the future is. And I do too. So
thanks for, giving your thoughts about this. So one technique that I found in some of your talk or resources that you shared before this conversation is that one thing called SudoLang, right? I find it quite interesting, right? So I think for some people who may not have heard about it, so tell us what is SudoLang and how can we use it in our, day-to-day work with AI?
Well, it's an interesting thing. This is going to take a minute or two to explain, right? But I think I found it through a web search, and somebody wrote a couple of Medium posts about a thing they call SudoLang. So it's SUDO lang, right? Just as a pun on pseudo. What the author was saying was that it would be great to go and actually create a language. It's kind of like a programming language that basically you can feed into an LLM that will go and generate code for you and do translations and all these other things. And so he described the language and had interesting features like constraints and stuff like this, and a very familiar syntax. And it wasn't quite like any other language. So it seemed like it was at a bit of a higher level because you could replace greater than with like the words greater than, for instance, and all this stuff, right? But the further you read down in the post, the further you realize what had happened. What he did is he asked ChatGPT, hey, I want to have a language which makes it easier for me to talk to you about programming and get the things that I want. Give me a language that does this. And actually, that's what the system did. It created SudoLang, right? And then it was even interesting and more tricky because he said, I asked for this again, and I asked for it. It's kind of like, can you give me a syntax that'll work for this that'll work even if I didn't tell you what the spec of SudoLang was, right? And it's interesting because it's like it goes full circle at that point. So it's really more like pointing in a direction. I don't think it's really like the language to learn or anything. And in the book I'm writing right now, I basically talk about something I call pigeon specification, which is really kind of like a pigeon language is a language, that people from different languages adopt so they can communicate with each other. It's usually some subset of two languages. But I can write like a test case using just a very brief test : this, assert that, right? I can type that in and basically say, give me this to me in JUnit, and it just gives it to me. And sometimes it's wrong, but I'm dealing with something small enough I can actually see what the results are, right? So I think we're going to see an awful lot more of this. People developing like private languages in much the same way that you might with people you work with. I remember hearing about a musical group many years ago, and somebody new joined the band, and they had serious trouble because the other musicians in the band could talk to each other with a wink and a nod. And this guy was new. He had no idea where they were going and what they were doing because these people knew they knew things about each other. And I think we're going to go and get into that symbiotic state with the coding assistants that we are using soon.
Speaking about symbiotic, relationship, right? Will AI be appropriate for us to do this TDD cycle where maybe we generate tests first and maybe AI help to verify and also create the business code, or maybe vice versa, that kind of stuff, like a real pair developer, although it's virtual, right? So is it something that you have seen it working before?
Yeah, I've done it. I basically do it, and I quite often get frustrated. I've seen people kind of carry it a bit further. Low and Falco has basically some videos on going and doing this. But I think it's a powerful approach. You just need to get the bugs out of it to some degree. The thing is that essentially it's like you write tests, and then you can go and sort of like have it generate code to satisfy the tests. What I've been finding is that essentially if you give it a whole bunch of tests at once, quite often it's going to do a reasonably good job for you. And you can run the test to see whether it has or not, right? But quite often I've done this thing where I basically start to go and say, okay, here's a test, here's another test, here's another test, here's another test, and have it generate code. And I'm asking it to go and always make sure that when it generates code, that it's going to satisfy all the tests I've shown it so far. And it's kind of like a little bit problematic with that right now. And it has to do with, I guess, context window problems and stuff along those lines. So I think, it's moving forward in a good way. I think there's so much you can learn just by going and taking a project and going and deleting all the source code and just giving all the tests to an AI system saying, write the code for me, right? The things that it's missing are things that you were missing in coverage, for that kind of thing. There's a lot of interesting stuff we can do in that space. It's going to get better. And I think TDD is still going to be around.
So you mentioned about context window. Maybe some people are not familiar with the concept. And I know that some of the LLM newer models always mention about this context thing, which gets larger and larger and larger. Tell us, what's the difference with having larger context window?
Well, it's like when you look at how an LLM works, it's kind of like it's rather deep and involved, many layers of neural networks. But it seems that, at least for a little while ago, when it basically goes and does inference, like of your prompt and processing and things, it's doing almost like a quadratic operation. It's just like the more that it needs in memory, the longer it's going to go and take to go and do things. And so for that reason, it's kind of like you have this thing that happens quite often where you're working in a session, and then after a period of time, you're asking it to do something, and then it goes and gives you an answer which makes it obvious that it doesn't know what you gave it like 10 minutes ago, right? And so it's kind of like, I call this kind of like performance degradation, right? That just has to do with the physics pretty much of like how computationally complex these operations happen to be. So it puts limitations on how much we can go and basically do at once. Now, the thing is, I've heard recently that some of the newer models, I think Gemini, claims that it has like, an infinite context window. And I haven't really kept up in that space to go and see whether those things still have that issue. I know some of the tools I'm using today still have that issue. But I think it's going to be with us regardless, because it's very much like, I took a lot of cognitive science in college, and it's just like the way humans interact with things. It's kind of like, if I divert your attention to over there, it's not going to be immediately top of mind, the thing that we were just talking about, and vice versa, right? We have attention, and it's relatively fixed because nothing can have infinite attention. It violates physics. So we're always going to have that thing of kind of like, what's in our attentive focus and what is not. And I think that basically understanding that's very useful to being effective with AI right now. So I hope that's a decent summary.
Yep. Thanks for explaining that. So we have spoken a lot of things about AI. Any things that we haven't spoken that you figure it out recently that people need to know about AI programming?
It's funny because in writing this, it seems like I've had a lot of topics and it's been like digging down deep in them. So recent isn't really the best way of going to put it. Here's one. Okay. And I just released on LinkedIn a couple of days ago a chapter when I was writing. And it's something I call Waywords, and it's kind of a powerful idea. And what it comes down to is this. It's kind of like, suppose that you're asking, the tool to go and refactor something, right? And you write a prompt to go and do this. And then it's kind of like, it does that, and you give it more test cases, and you discover you need to change the prompt a bit and change it a little bit more. At that point, you probably want to name this thing, right? You really want to go and say, okay, this is an operation called da 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 da. And then basically you can just, in English, or your language, just go ahead and just sort of like use that as a piece of new nomenclature and terminology. And so it's just like introducing a method name or a variable. One thing you can do sometimes is go and say, okay, please, now that I define this thing, give me a summary prompt, give me a prompt that I can use to put into another session so that we can go and actually do the same operations. Doesn't always work, but it's getting better. But I really find a lot of utility in this thing of naming things as you go along when you're working with things. They can just be, okay, well, this example I just created, call this response ABC. And then you can go back and say, well, when we did ABC, that thing, right? It's going and creating these handles for going and dealing with things. And very useful thing to go and use.
So speaking about this nomenclature, right, we just spoken about the context window and the different sessions. Do you have to sometimes copy and paste the prompts that you had previously in some of the notes, and then when you work on the different sessions, maybe some couple of days later, that you have to paste it back, load sort of the memory or the cognitive thing to the AI brain, and then try again? Is that something that is also commonly done by people who are using AI?
Well, I think for the most part, I kind of cheat by going basically making the source code the thing, right? It's kind of like, if I know that I can transport source code from one session to another, that's kind of good. But when I have durable things I'm working on, Yeah, it gets down to copying things back and forth between sessions or just sort of redescribing something. And quite often I can get it back to the point where I feel it's usable. So yeah, it's kind of problematic with that. So I'm looking forward to things getting a bit better in that space. I think there's somebody was talking about actually doing this and calling them skills. So you can actually sort of like make almost like plugins for particular things. And there's many different ways to go and tuning LLMs to go and sort of like facilitate this. But to the point where we can actually create user-defined skills and move them across sessions is valuable. The other thing I would say is that even if we have an infinite context window, sessions by themselves are so valuable because quite often I'll keep one main session and I'll basically just create small ones I dispose of, right? And it's almost like managing tabs in a browser, right? It's kind of like, here's the main tab I'm working in. I've got 5, 6, 7, 8. And you have to kind of know when to get rid of them and when to keep them. But it's nice to go and have a good separated space where you can actually go and do some working things and experiments without actually sort of corrupting or degrading performance in the original session you have.
I know it's a fast changing world these days, right? But any favorite tools that you use these days, related to AI and coding, or is it
This
Copilot,
is going to be so
the best
weird
thing?
because there are Copilot is great, but it's one of the things I kind of am drawing distinction between is that, let's see, we're in a in the world right now, the market is in this place where every time that you make a general LLM better, it's kind of like you're kind of eating into the space where people do specialty things, right? So it's kind of like you can try to specialize the tool, but if people can just wait for the next general LLM to do things, then what's it do, right? But I think it's starting to separate now, and you're starting to see decent coding tools that have their own utility. But what I like to do is, even if I'm using Copilot or I'm using CodeScene or all these other tools, is have my own window open in something like Claude, for instance, whatever I consider to be the best LLM at the moment, and basically do my more ideation work in that space because they aren't clamped down. And by what I mean by that is that sometimes you'll be using a tool in an IDE and you'll say, well, give me 3 other approaches for going and doing this, or tell me more about this thing in the domain. And they'll say, no, I'm sorry, I'm here to help you with your code and refactoring. And that's it. And you don't, know what the tools are good for, but always keep your most capable general tool next to you in order to go and actually do the things that are going to help you have high creative value. So,
Yeah, I personally also subscribe to many AI tools, right? So I think sometimes you just, pick
same
the
here.
best from whatever AI that you use, right? And sometimes, yeah, one works
Yeah.
best for certain contexts and the other works best for others. So I think this
Yeah.
landscape is changing really, really fast. So I think there will be more exciting stuff happening within this space. But one thing for sure, like what you said, I think probably developers' role won't be like gone, right? People are still having to problem solve something, right? And especially also the understanding about domain, right? I think that's still one key. So thank you so much for this exciting talk, Michael. Unfortunately, we reached the end of our conversation. But before I let you go, I have one last question that I always ask my guests. I call this 3 technical leadership wisdom. You can think of it just like advice that you want to give to us, the listeners here. So maybe you can share your version of the wisdom.
Oh, yeah. It's kind of funny because I was looking back through, the other, some of your earlier episodes, and there's a lot of things about basically managing organizations and basically dealing with people and stuff like that. Purely from a technical point of view, the thing I want to go and basically mention is that basically looking for things that aren't there is very valuable, right? And I think just generally in life, it's kind of like if you can detect the absence of something that should be there, right, then you're in a good position. The Legacy Code book came about because I realized it's like, this is a tough problem and nobody's going to touch it. Nobody wants to touch this problem. So it's like, okay, might as well do this, right? So developing a sense for the absence of things is extremely valuable. The other is like, number 2, I guess, would be basically learning as many domains as you can, right? Really digging into things because it's like the more impressions that you get of different things, the more you have to draw upon when you're formulating solutions yourself, right? And this is almost like how an LLM works in a way, right? It basically has read almost all the online content in the world. And one thing that makes it very effective is because it has that breadth, right? So you'll quite often see yourself, I'm reading about this and you say, wow, that's very close to this thing over there. Is there a commonality here? And then you start asking questions and going deep, right? And I guess the third thing is really just maintain your curiosity more than anything else. Everybody who's in software development is in a position to be able to learn more about many adjacent things. You're able to learn more about business, you're able to learn more about management, and the resources are available to all of us. It's just a question of actually going there and dealing with those things. So I guess those are the main things. And those have served me well through my career, and I I don't know to what degree people can trick themselves into curiosity if they're not terribly curious, but yeah, I hope they can because it's fun. To me, it's fun. So yeah.
I'm sure when people opt for the programmer's job, I think there is a sense of curiosity because otherwise, right? I mean, they can't be a good programmer anyway. So
sure. Just some of the most interesting conversations we've had at conferences. They have nothing to do with software. Just people are just very into things and curious. So sorry. Yeah.
no problem. So thanks again for this conversation. So if people like this conversation or they want to reach out or check out with you certain stuff, is there a place where they can reach out online?
Sure. There's my Substack, Michael Feathers at substack.com. There's also on X or Twitter is M Feathers. So just either one of those places is perfectly fine to go and reach me. You can also search for the book AI Assisted Programming on ReamPub. And it's early days. I'm about 15% done, but I'm releasing new chapters every week or so. So,
right.
Thanks.
I don't know how far it can be like a legacy code book, right? Which is like very classic, but I hope I can see the book in a full form, right? And learn how to use the AI much better. So thanks for writing the book as well.
Sure. Thank you.